Hi, this is Sonali from Coders for Coders. Today I'll talk about a topic that kept me puzzled for quite some time. What is microservice? In this video, we'll discuss about the definition of microservice, its pros and cons, why there is a need of microservice in the IT industry. That is, we'll try to trace back its origin and see how it has evolved from the single process monolith. So we'll discuss about the different architectures that are present in the industry: single process monolith, front-end back-end monolith, modular monolith, service-oriented architecture, and micro-frontends. We'll also try to see how the microservice is related to the buzzwords in the industry like Docker, Kubernetes, AWS, and Google Cloud. So let's try to define what microservices are. Microservices are individual, independently deployable application components which are self-contained and are exposed through lightweight, normally HTTP based APIs. For example, if this is a pizza ordering website and microservice A is responsible for browsing activities, microservice B is responsible for cart management, and microservice C is responsible for bill payment. Suppose there is a national holiday and there is an upsurge in the browsing activity. The load will increase in the microservice A, so it will need more servers. And we don't need to waste hardware on microservice B and C. So the independent deployability feature of microservice will be of advantage here. So we can scale up or scale down our microservice based on the requirement. The other feature is that since A, B and C are independent from each other, if cart management and bill payment goes down, the browsing service will still be up, since it's independent from service B and service C. So if we try to analyze the pros and cons of microservice, the two pros can be independent deployability and improved scalability. Since the microservices are independently deployable, features can be split into different microservices which can be distributed among different teams, which can focus on that feature, resulting in faster development and updates. The other pro could be the fault isolation can be easy in microservice to prevent cascaded failures which can lead to the crashing of app. If you want to talk about the cons of microservice, it can be related to networks because microservices communicate over network, usually HTTP based APIs, so there can be latency issues because of network. Since network is involved, there are higher security risks. Moreover, microservices have a higher upfront cost, that is hosting infrastructure with security and maintenance support. So when we usually test a new feature or in startups, we start with monolith and we slowly, step by step, transit to microservice. So that's it for the pros and cons of microservice. Microservices usually run in containers, which run on VM, which run on server, which sit in rack, which sit in data centers, which is a part of collection of data centers called as cloud. These containers can be a single container that is running on the entire VM, virtual machine, or multiple containers can run on a single VM. So in order to maintain these containers that can be running across different VMs, we have something called as Kubernetes. It's an orchestration software that can basically help us maintain containers. So here comes the AWS and Google Cloud, which can actually run these Kubernetes clusters. So now that we are a bit clearer on what microservices are, let's try to understand why do we need microservice in the IT industry. So it all started with a single process monolith. Here all the code is written in a single application which is tested and deployed together. The limitation of it would be a small change would require the testing of the entire application, which would be a waste of both time as well as effort. So then came the front-end and the back-end monolith. Here there was more focused development. For example, a front-end developer does not need to know about the database and its connections. He can focus on the user experience and design. In the single process monolith, when the front-end and the back-end were linked, any change in the back-end would require a change in the front-end as well. For example, if the back-end is written in Java and we want to switch to PHP, we need to change the front-end code as well. But here, in the front-end back-end monolith, since the front-end and the back-end are separated, if we want to switch from a front-end framework, say Angular, to React, no back-end changes would require. We can isolate the front-end and back-end. So the limitation here would be similar, that we would need to test the entire back-end for small code changes. Then came the modular monolith. Here the entire backend is divided into small modules. For example, we can run a Gradle test task on module A. We do not need to run it on the entire application. Then came the service-oriented architecture. Here the entire backend is divided into different services based on functionality. For example, service A can work on a different function than service B, and they can interact with each other over in the network, which would increase the code reusability. But the limitation here would be that all these services would need to connect to the front end via our enterprise service bus. So whenever a new service, say service C, is added, the entire enterprise service bus need to be scaled up, which can lead to large ESPs. Moreover, here ESPs are single points of failure. Besides this, since services can share a common database and are not completely independent, for example, we want to scale up service A. Since service A and service B share a common database, additional space would be required to be allocated on the server, which is basically a hardware wastage. So then came the microservices, where the entire application is divided into independently deployable modules which actually own their own data. We have already discussed about the pros of the microservice: independent deployability, improved scalability, better code management and development. So this is the architecture that is currently being used in the industry right now. In the future, we might switch to micro-frontends. Here, we have tried to split the front end as well, so that the software team would be responsible for the end-to-end delivery of the product. So in a single page application, different teams will have complete ownership of different components. That's all for this video. In the next video, we'll start with a project on microservice using Spring Boot to get a better understanding of them. Thanks for watching this video. If you have any questions, please do leave them in the comment section below. If you like the video, please hit the like and subscribe button.